Well, good afternoon already, everyone. How is everyone doing? Everybody awake? Anybody sleeping? That guy over there is sleeping. So first of all, thank you very much for bringing me out of the Netherlands. I expected a bit warmer weather, but you are making it warm. Thank you very much for being all of us together today in Spain, in Madrid. My name is José Pozo. I'm the Chief Technology Observer of EPIC. My job is to observe you. And it means a lot to me to be in Madrid. Why? Because Madrid means a lot to me in many different ways. Many of you are subscribed to my YouTube channel. I know that. Thank you very much for all your support in YouTube. My job is to really organize these meetings in which people share ideas. And I have all of them in YouTube. I organized over the pandemic time 108 online meetings. And it was really great to get the experience and also to get people to meet online. That made a revolution for me. But also, in addition to being in Madrid, it means a lot to me to be in Spain. First, because as my accent shows, I'm from Almeria, so I don't really speak Spanish. But the second one is that I am in a country that is really booming in photonic integrated circuits. Many of the people in Europe are looking at photonic integrated circuits, and they think about Belgium, the Netherlands, they think about the Berlin area, they think about Switzerland. What we have here in Spain is amazing, really unique. We have perhaps definitely the best design house and support for ecosystem in the world. And Hitachi saw it, and that's VLC Photonics, of course. We have foundries, silicon nitride foundries already operating for over a decade in Barcelona. We have indium phosphide foundries around the corner coming in Spain. We have packaging. We have the packaging technologies that bring in photonic integrated circuits to space applications and to large volume applications. Just here in Madrid, 20 minutes by taxi away, right, Demetrio? Around the corner. We have one of the strongest ecosystems in Europe. Not only that, we have success stories. For example, the company that you see there at the top, QSite, was the first company in Europe to have a photonic integrated circuit-based quantum random number generator in the market. We have Itronics, a company that everyone in the world is looking at because it's one of the revolutions in programmable photonics. Material LiDAR, the European Space Agency has selected Material LiDAR to be the first LiDAR company to be incubated for the European Space Agency. And the list goes on. This is what we have in Spain. It's really unique. And I must say, it makes me proud to be part of this ecosystem because many of you have been working in photonic integrated circuits at the same time as me. We have met in Eindhoven, we have been trained by the Mindsmith community, and now we're going all around the world to advocate for this technology that's going to revolutionize the world. So for that, thank you, Ignacio Esquivias, thank you, Demetrio Lopez, thank you, Antonio Perez, for bringing me here and share my passion with you. Yes, indeed, I am the Chief Technology Observer of EPIC. When I joined EPIC, EPIC had 200 members. And it had one person, Carlos Lee, you all know him. And today, we have become the biggest photonic industry association in the world. Actually, a few minutes ago, Nokia was announced as our member 750. So we are now the biggest association in the world, and we are European. And the CTO is Spanish, from Almeria. And he speaks on behalf of 15 people who dedicate their life fully to the integrated photonics community, to the full photonics ecosystem. And that's all I have to say about EPIC, because all I want to say to you is that when you organize meetings, the most important thing of these meetings is to make sure that all of you get out with at least one business lead, one idea to collaborate. That's what they organized, this 100 meetings. This is the one they organized in the topic of pluggable transceivers last September. And we brought the key companies and understand from them what are their needs. And every meeting should finish with a summary of your ideas. For example, this one on pluggable transceivers, our final conclusion was that we need to work together on having a generic DSP because every company in pluggable transceivers was developing their own DSP, and that made absolutely no sense. We were going slower. Organized, for example, another one in photonic integrated circuits for sensing applications. And there, our conclusion was very clearly that we needed to have cost effectiveness versus volume production when it came to the integration with the light sources, something that you all have seen today here. I organized, for example, well, many, 100. And then it all came back to this. I have actually a drinking game, although I stopped drinking 3 years ago. For every time we see this light, we need to drink. Somebody in the room knows what I'm talking about. And I stopped drinking 3 years ago, luckily, because I would have drunk a lot. This is the way that people saw the indium phosphide technology as a platform in which you could integrate almost every functionality on a photonic chip. It was fantastic. You could do anything you wanted because every single functionality that you need in photonics, from an optical band to a chip. And that was really fantastic because, for example, a coherent transceiver was something that we could integrate in a photonic chip. A whole coherent transceiver. We had the modulator, we had the photodiodes, and with that idea, one of our success stories in the European ecosystem, Effect Photonics. Effect Photonics, the CTO of Effect Photonics, body white doctor, was working with Pascual and with me in the Technical University of Eindhoven. We drank a lot of beer together. Now it's a company with 170 people and developing the transceivers for many potential users in the world. And with that idea, you could integrate every single functionality of a photonic integrated circuit on a chip. I mean, the last years that resonated with many. So many of you have seen that this market, pluggable transceiver, is actually consolidating really quickly. And we are seeing lots of very strong acquisitions there. But you don't see there, for whatever reason, which I have my opinion and you have yours, are European companies. And this is a technology that was actually invented, discovered, developed by Europeans. You don't see European companies on the large acquisitions in the manufacturing. What is going on? Well, let me tell you what's going on. Well, I don't know what's going on, but let me tell you my opinion of what's going on. We have this fantastic transceiver by Effect Photonics. We actually can do something fantastic, which is utilize the unique selling points of indium phosphide technology. And then we go to the market and we say, okay, this coherent transceiver is going to actually be the right coherent transceiver module for 100G and 400G coherent, which is the biggest tendency of the European or the world industry, the biggest tendency. Actually, when you look at the device from Effect Photonics, is QSFP-DD compatible. You look at the technology trend, and it's really where we are going. And even if you look at the market, you say, no, but actually, even if you go in the next years, the amount of technology that's going to go into that direction is booming. We're going to be 40% worldwide. I mean, there's a lot of transceivers in China, 40% worldwide. So it is the right way to go. So what is really happening? But what is really happening, and I'm going to skip this, is that this industry, when it comes to large volume production, this industry will always be dominated by the semiconductor companies. Not by the photonic companies, but the semiconductor companies. The whole tendency, many of you are hearing lately, the word COBO and the word co-packaged optics. Basically, this is nothing more than saying that the laser will be something external to the rest of the optical module. Just to make it simple. As simple as that. You can make it more complicated, but as simple as that. How do the semiconductor companies see this? Indium phosphide, as Guillermo Carpintero said before, is the best material to create 1.55 light. I fully agree, and everybody agrees. So Intel, 2019, they came up, epic member Intel, they came up with this revolutionary breakthrough. For those of you who have been working in semiconductor lasers, they say, are you sure it's revolutionary? Well, I'm not. But the whole industry saw this as revolutionary. They actually made an indium phosphide laser on the top of a silicon chip, as simple as that. They characterized it. Many of you are professors at universities, they have PhD students, you put them in the lab and they measure this. I have measured this in Bristol 2007, so we all know how to measure that. I missed the Happy Paoli game, but apart from that, it's a characterization of a laser, and there's nothing special about it. Why is that a breakthrough? It's a breakthrough because it came from the semiconductor companies. The STMicroelectronics, the Intel, the Infineon, the companies that are taking this to the volume production, the companies that are normally missing are 99% of the meetings. Not only today, 99% of the photonic meetings, these companies are missing. However, they are driving the industry. They drive the industry because they think semiconductors. They don't think photonics. They think semiconductor. They talk They think about the PCB as being the platform, and they think about if you can do it passively aligned, you do it passively aligned. If you can avoid hermetic packaging, you avoid hermetic packaging. If you can do wafer level packaging, you do wafer level packaging. That's the way that they think. And that's why things that when we look at it ourselves with our eyes, we don't see them as breakthroughs. We definitely not. I don't see anything special there. But they go to the volume production ultra fast. And that is what we really are missing there. And I look at the transceiver. I took a few pictures now that I'm going to show you. Thanks for all the EPIC members and collaborators who allow me to show these pictures. This is the 100G transceiver. I'm sorry that you cannot see the title, but I can read you down. This is a CWDM 400G transceiver of Intel. It has a transceiver, a receiver block. Let's look at it deeply. You will see how amazing it is. We zoom in. It's an SEM picture, and there you see the laser and the mass under modulators there very clearly. Don't worry, I took a bigger picture. So you see the modules there with the indium phosphide laser bonded on the silicon. The indium phosphide chiplets bonded on the silicon. This is the same laser that you saw in the previous slide. This is the way that the silicon photonics transceiver of Intel is working. It's working based on indium phosphide technology, as simple as it was shown in these pictures, thought as a semiconductor revolution. And this is not the only one. Even the one from Finisar goes in a very similar way. So this is the transceiver block. Let me zoom in. I will go quickly through this. And I can show you already that here is where you have the indium phosphide lasers. Here, not integrated in any way, just placed, passively aligned, bonded, wire bonded. As simple as that. That is a volume-produced transceiver chip. And when you compare this to the one that was taken by Effect Photonics in the beginning, you would say it's lower tech. It's not. It's driven by semiconductor manufacturers. And that is my vision here, and that's what I asked the person from Smart Photonics before. What is the difference between doing a gain chip or doing the whole full picture? Well, the gain chips are still something that is driving all the major industry. And the mass standard modulator has to be as close as possible to the laser, and that's the opportunity for us. Not to bring all the functionality possible in a chip. That's perhaps marketing. Is to solve problems. And today, with the indium phosphide technology, we can solve problems. One of the companies that saw this very quickly is a company in Enschede, north of the Netherlands. Company Chilas, spin-off, partner company of the company Lyonics that was mentioned a lot today. Basically, what they said is something very similar to what Guillermo said today, which is that if we take a gain chip from an indium phosphide foundry and a silicon nitride chip, we can get the best of both worlds. The whole magic here, as we all are thinking, and I'm sure Demetrio Lopez from ALTER is thinking, is how do you do this with the minimal reflections, with the maximum accuracy, with the volume production, so you can enable a product. In this case, is a broadly tunable laser. Well, that is our opportunity. When it comes to hybrid peaks, that is an opportunity. And coming back with my Spanish flag today, I'm very happy to say that in Spain, we are setting up also a center for hybrid peak manufacturing in Valencia, UPV Fab. We have such an amazing opportunity for Spain to be leading photonic integrated circuits, photonic integrated circuits. Another one, LiDAR. I love LiDAR. This has been my passion and hobby for the last decade. When you talk about the market of LiDAR, you talk about the market reports, you talk about the LiDAR is a system in which you are doing illumination, imaging, and photo detection on the same system. As simple as that, but also a system that is limited by having very accurate detectors. So very smart people decided to not play that game, decided to do the FNCW LiDAR, the continuous wave LiDAR. So basically, for those of you, because the presentation from Antonio Perez was fantastic, but for those of you who don't know really what is continuous wave LiDAR, let me just tell you that you are a pedestrian and a car, automated car without a driver, sees you, well, basically sends a pulse, bounces back in you, and then measures the time that takes the pulse to go back and forth, and that limits the position. That's very interesting for that. What happens if you have another car and you're using the same LiDAR? Then you have interference. What happens is it's a very bright day, and then there is light that is coming to your detectors and saturating them. What happens if you have the possibility of being damaged in your eyes because you're using visible light? Well, people with photonic integrated circuit background, they said, we are not going to use visible light, but you're going to use indium phosphide technology, which is the best. Guillermo said already many times, the best light source for 1550. We can use also the possibility of doing coherent detection and having nothing more than a coherent transceiver. And if you look at the setup, you look at the, I couldn't take the right to show pictures of coherent transceivers for LiDAR, but it looks really similar to the one that, as I said before, Effect Photonics using indium phosphide technology has put for the first time in the market together with Infinera from the US. A key opportunity for the LiDAR industry, using 1550 and using photonic integrated circuits and using not the high power and limiting all the interference. With that opportunity, what I do? I bring the EPIC members active on this. I organize an online technology meeting. It's a pity that you cannot get the talk. But last 6th of September, I organized an online technology meeting on the 106 with the key companies in EPIC that were doing technology for that FNCW LiDAR. And after 2 hours of fantastic discussion, they came up with that the problem of this whole industry is that you have the transceiver already ready. Actually, from the technology, many of the customers of some of the foundries I have spoken today already had the entire system ready. The problem was to put outside that amplifier that will give them enough power. Really happy to see that ALTER Technology is already working on that roadmap to go to the space application for that. But still, we have that particular challenge, which is not a photonic integrated challenge, but all the rest is solved. And that's one of the reasons why I think this is one of the booming trends that we're going to come in the next years. Another one is the medical. This one makes us all particularly excited because many of you already saw that I'm wearing the Apple Watch. The amount of innovation that has been done in the last 5 years for medical wearables is unmatchable. I am amazed on how much innovation was done and how little photonics was enabling that innovation, to be honest. So I bought a market report, which I share with you all of them for free. All the market reports that I'm showing today are, because you are most of you EPIC members, you can download all of them for free. And in that market report, we actually bought the intelligence to understand what was missing. And one of the reasons why they said that there is very little innovation with photonics is because we really were still not having the right detectors, the right photodiodes for that particular market segment. Luckily, a friend of some people in the room, including me, Andy Rickman, had the right idea of focusing photonic integrated circuits using silicon photonics as a platform, indium phosphide light source, to make the first biosensor based on photonic integrated circuits. You know what? Apple invested, well, a fruit company invested on them. And then you have there the Andy Rickman wearing that watch from the fruit company and telling us that this is the way that he's going now to use photonic integrated circuits for that technology. That company went public earlier this year. For us, what's interesting is that it's opening the eyes of many, many people. How is that opening the eyes? Well, first of all, of course, I did organize a meeting to discuss that technology. And in that meeting, we discussed about what was the big challenge for us, the next step big challenge. And the next step challenge that they had there was to couple the light in and out of the chip using micro optics. And at the end of the day, also using the right packaging technologies that we already saw from ALTER Technologies. I have to say that when it comes to photonic integrated circuit packaging, we have amazing companies in Europe. ALTER, which acquired Optocap a few years ago, is one of them. And what we need to do now is to align this packaging technology so we don't have the problem that Una said to us a few minutes ago, which is that there are really standardized rules, that every company is sending you the chips, and it's so hard for you to package them as possible. So what we tried to do is to align the industry, setting up a set of packaging rules. For many of you know the initiative picks up. You can download the packaging rules from there, and the packaging companies can apply them in the one. At the end of the day, standards are as useful as people use them. And in this sense, this is a de facto standard. So there are some design rules there. But that's only part of the solution, because as Una said very clearly, 80% is 80% of the cost is the cost of the packaging, and includes also the cost of testing, yield, components. For me, there is still a big challenge there. The big challenge of photonic integration is testing. It's testing, and when it comes to indium phosphide, which doesn't emit light vertically, is double testing. It's a really, really big problem. And there, I really always was dreaming of a place in which the smart photonics could send the wafers, and then they would test them and say if the wafers were okay or not. For me, that was something that was needed desperately, the photonic industry. But we didn't have the equipment, we didn't have the process, we didn't have the standards, the design rules, the test structures, we didn't have any of that. In the last years, I was dreaming that a company would take the lead on that. I was very happy that a company in Germany took the lead on that. Bicontext said, okay, we're going to set up the same machines that we do for the packaging, so they can actually do also the testing. That's what followed by all the other equipment manufacturers. And then they set up really set up to do the wafer level testing of photonic integrated circuits. You know what was the first company that independently could take that machine and use it for testing chips from foundries? You know what it was? Who does know what it was? In Valencia, Spain, first company that was offering testing independently from the foundry to the customer. In Valencia, Spain, using and addressing the big challenge. And challenges are coming stronger and stronger. I can tell you one thing. When it comes to photonic integrated circuits, not just indium phosphide, things are becoming very complex. You heard from Ipronics before about the programmable photonic integrated circuits. This is how a programmable photonic integrated circuit looks like. So you want packaging challenges, Una? 10,000 optical elements, tens of RF signals, 100 optical input outputs. This is what the packaging of programmable chips look like. And everybody wants programmable chips because it's a generic chip that can actually serve many applications. You can make it in volume production for niche markets. Everybody wants them. You have to package it. And there is when something is really coming our way. It makes me really excited. I get excited about challenges. I met one of the chair people of this conference, and Antonio Perez. We were both studying chaos and nonlinear dynamics. So we really love challenges. And I also studied quantum technologies when quantum wasn't cool. Now everybody studies quantum, and it's so fantastic. And I do quantum. Well, in 20 years ago, quantum wasn't cool at all. We couldn't really get a girlfriend saying that we do quantum technologies. So in quantum technologies, now we are seeing that, let me skip this. Yeah, sorry about that. In quantum technology, we are seeing now that there is a big trend. So everybody says quantum because quantum really brings you money, brings you attention. Alter has OptoCap people in the location in Glasgow. You can tell how many quantum projects they are active in. Some of them related to photonics, some of them they are not related to photonics. For me, I separate quantum technology into two things. The first one is the generation of qubits. So basically, qubits are the units of information in quantum technologies. A bit can be 1 and 0, a qubit can be anything between 0 and 1 aspect. And the others, the quantum sensors, which are very, very efficient detectors. But we call them quantum sensors because the quantum world really, really brings you a lot of interest in this market. Together with a company in Scotland as well, we actually, CSA Catapult, we managed to get an overview of the opportunities that quantum technologies was bringing to the photonics industry. So basically, many of you have heard that quantum can solve everybody's problems from defense to space, especially the digital economy and health. We really wanted to connect that to what photonics really can do. And they even separated it into two different areas of expertise. The area of quantum timing and quantum sensing, and the area of the LiDAR and the communications. And there we also, and there was one problem. The biggest problem that we have in the photonic industry, we need very, very good detectors and light sources, that's clear. But others, we really want to have a very strong packaging of the silicon and the compound semiconductors, in this case, 3-5s. That's why there is so many new projects in which, this is what I'm saying, the gain chip of indium phosphide being coupled to the silicon photonics is going to be one of the biggest challenges. I didn't want to take most of the time. So what I'm going to tell you now is that the slides are public, you're going to get them. If you want to see me more often, please subscribe to the Epic Photonics YouTube channel. I am always there. On the 6th of December, I have a beautiful online technology meeting on medical devices. If you want to know more about wearables. And if you want to know more about the qubit generation, next Thursday, I have also an online meeting on qubit generation. And on that, I will let you once again, thank you very much for bringing me to Madrid. I love this city. Thank you very much.
Thank you very much, José. Now we are time for some questions. Any questions here in the room? People online.
How would you see evolving platforms
First of all, I would like to say that it's amazing what Alcyon is doing. So Jimena is the CEO of Alcyon, one of the first IP companies in the Photonic Integrated Circuit ecosystem. When you talk about IP companies to electronics people, they fully understand. In the photonics people, we are 20 years behind, and we need more IP companies in the Photonic Integrated Circuits. So thank you very much for your hard work on that. I am so happy that we are no longer talking about silicon photonics versus indium phosphide. That was such a boring battle. I think it's over. We no longer talk about that. I think that the next big thing is that what Guillermo said, that sometimes you have to choose the right technology. The next stage, the Guillermo 2.0, is that now you have to choose the right functionalities and making sure that we have a hybrid platform that can bring all of it together. And as I try to convey the message, at the end of the day will be, for most of the production applications, will be the semiconductor companies that will want to bring their technology. One of the slides I wanted to show, but then I spoke too long in the beginning, is that there's a company in Switzerland called Ligentech. And Ligentech just signed an agreement with a company, XFAB, which is one of the electronics foundries that we have in Europe, to transfer the silicon technology to them. That's only the first step. The next step is going to be that we're going to need light sources for that particular technology transfer. So light sources will come. And the next step will be that we will need modulators. Some modulators will come. And that's the way that we're going to be seeing. At the end of the day, will be the semiconductor company, the one that will drive that level. And we think we need to think less about making everything in one photonic chip and more about making everything in one optoelectronic chip. That's the tendency, and I'm very happy with this because you cannot imagine 10 years ago how much we had to argue on which is the best photonic integrated circuit platform. It was indium phosphide silicon photonic.
Any other question? Any question in the chat? Okay, then. Thank you, José.